This is the Chapter 10 test review for 4th grade Go Math. Number 1, Gavin is designing a kite. He sketched a picture of the kite. How many right angles does the kite have? Now remember, a right angle is 90 degrees, so it makes a perfect corner. And if you're not sure, you can always use a corner of a piece of paper, like a Post-it note, and you can check just by putting it along one edge, and you can see if there are any right angles. And we can see here that there are no right angles on this, so it has 0 right angles. Okay, the next one, write the letter of a triangle under its correct classification. So we're going to decide if it's acute, obtuse, or right. Well, we can easily do the right because any right triangles will have this cute little square at the bottom. So we know triangle A is right, and we know triangle E is right. So those ones are done. An obtuse triangle is anything that has one angle that is bigger than 90 degrees. Only one angle. It doesn't need to have all 3. There's only one angle that's obtuse. So I can see this is pretty small, this is pretty small, but I can check this last angle. And by putting my little sticky note on there, I can see that it's open wider than a corner. So that is obtuse. On this one, if I put my little corner on here, I can see that none of them make a perfect corner or bigger, so I know that those are all acute. They're less than 90 degrees. This one, I can tell that this angle here is more than 90 degrees. It's bigger than a corner, so that's going to be an obtuse. And then this one, we can see we have 3 small little angles, which are acute angles, less than 90 degrees, so it's an acute triangle. All right, so the next one, select the angles that identify an obtuse triangle. So on an obtuse triangle, we know that one of the angles is obtuse, and we know that the other 2 angles have to be acute because we can't have a triangle that has more than one, I can't spell today. We can't have a triangle that has more than one obtuse angle, and we can't have a triangle that has an obtuse and a right angle. So if it has an acute, acute, and acute, we know that that is an acute triangle, so that one's out. An acute, acute, obtuse, that's 2 acutes and 1 obtuse, so yes, that would work. Right, acute, acute would make a right triangle. And obtuse, right, acute is not possible because you can't have obtuse and right in the same triangle. Okay, on to the next one. So looking at this, it says write the word that describes the part of the figure A written below. The biggest tip I can give you on this is to pay attention to the symbol that is on the top of the image of the name. Okay, so we can see that EB, technically it looks like it's a ray because there's an angle right, or an arrow right here. That's why I'm going to tell you to pay attention to this symbol. So that is, because it ends on both sides, a line segment. The next one, it has arrows on both sides, so that makes it a line. And the next one, it has a stopping point on one side and an arrow on the other, which makes it a ray. Now we're into the angles, and we have to decide what kind of angle they are. So if we look at EBJ, so here's EBG, so EBG, okay, EBG, since this is a corner, this is also, so it is a right angle. And then we have angle CGB, it's a little bit less than a perfect corner, so this is an acute angle. Or acute triangle, I mean. No, you're right, it's an angle. I'm sorry, I'm getting all mixed up. All right, so the next one, which term best describes the figure below? Well, it's crossing. There's 2 things that are crossing, and they're making right angles. So I know that they are perpendicular. And I know that both of these are lines. They are perpendicular lines. You may also see this symbol. Remember, this is a symbol for perpendicular. So they are perpendicular lines. Number 6. Naomi leaves for her trip to Los Angeles on the 12th day of August. Since August is the 8th month, Naomi wrote the date as shown, 8/12. Naomi says that all the numbers she wrote have line symmetry. Is she correct? Well, I can see that I can cut the 8 in half here, and I could actually cut it in half here. And on this one, I could cut it in half diagonal, right, like this, and make it symmetrical. I could cut my 1 in half like this or like this, but the 2 cannot be cut in half. So then no, she is not correct because 2 does not have line symmetry. Moving on. Question number 7 says that Max made a pennant that looks like a triangle. How can we classify the triangle based on its angles? So looking at this angle, do we have any right? None of these are right angles. None of these are bigger than 90 degrees. So we know that this is an acute triangle. Remember that a right triangle has one right angle, and an obtuse triangle has one obtuse angle, and the other angles are automatically acute. Okay, choose the labels to make this statement true. So we're trying to find something, one line is parallel to another line. Now before we mark it, let's see which ones are parallel. And I'm just going to highlight it so we can see it better. So this line right here is parallel to this one. The reason I do that is you'll notice that GH is on both options. Okay, so we've got to pay close attention. CD is also on both sides. So we can see here's AB and we need CD. So here's line AB and it's parallel to line CD. Number 9, classify the quadrilateral, select all that apply. Well, we know this is a quadrilateral because it has 4 sides. And by definition, a trapezoid has at least one set of parallel sides. So these ones are parallel. Since they're parallel, it's a trapezoid. We know that a parallelogram has 2 sets of parallel sides. Well, these are parallel and these are parallel. So this does qualify as a parallelogram. We know the definition of a rectangle is that it has 4 right angles. I can see that it has 4 right angles, so that would be correct. The definition of a rhombus is that it has to have 4 equal sides. Well, I can see that these 2 are equal, but they are not equal to these 2. So they are not all the same size, so it's not a rhombus. And if it's not a rhombus, I know a square is 4 right angles and 4 equal sides, so I know it can't be either one of those. Okay, number 9, Lily designed a deck in her backyard that looks like a quadrilateral. Well, we know quadrilateral is 4 sides, and it only has 1 pair of parallel sides. Okay. 1 set of parallel sides, so I'm going to go ahead and draw my parallel sides. The other 2 are not parallel. So when I draw that, I can see that the quadrilateral is a trapezoid. Okay, number 11 says that we're going to figure out how many lines of symmetry these shapes have. So on this heart, I know I can cut it in half this way, but there's no other ways I can cut it. So I'm going to match that to the line, 1 line of symmetry. Now this shape, I could cut it here and it would be the same. I could have also cut it right here and folded it on top of each other and it would have been the same. There's really no, if I cut it here, that would not be the same. It would be opposite. Same with this diagonal. So this one has 2 lines of symmetry. Okay, on this F, there's really nowhere I can cut this or fold this to make it the same. So that means that is 0 lines of symmetry. And then more than 2 would be this one. And the reason for that, I can cut it in half. I can cut it in half horizontal. I can cut it on the diagonals. And those are all lines of symmetry. So it has more than 2 lines of symmetry. Remember, it has to be the same if I folded it on top of each other. Sometimes it gets a little, you can get it mixed up by thinking that it looks the same, but if it's a mirror image, that's not the same as line symmetry. All right, so Barb drew the pattern shown. Use squares to complete the pattern. So we can see here's the first one, and I can see that they added this here and then this here. So I added 1 square to the top and bottom. And then I can see on the next one I add another square. So I am guessing, and now I can see that there's 3 here, 3 going across. So I'm going to start off with my one in the middle. Okay. It stays 3 in the middle the whole time. And then I want to make sure I have 4 here. And the reason I'm doing 4 is because I can see there's none, or there's none, then there's 1, then there's 2 extra, and now there's 3 extra, so there's 4 total. And then I'm going to do the same thing on this side. 1, 2, 3, 4. And I can just double check. I've added 1 there, I've added 1 there. Now there's 5 going across the top, 5 going across the bottom, so I've continued the pattern. Number 13, Claudia drew the figure below. Draw a line of symmetry on Claudia's figure. Well, I know that I can cut this in half right here, and it will, if I fold that, it'll be perfect. So line of symmetry. Write the word or words that best describe the figure. Well, since this ends on one side and has an arrow on the other, I know this is a ray. How many acute angles does a right triangle have? So if I draw a right triangle, I know it has to be a right triangle because one angle is a right angle. If I do that, it has how many acute angles? Well, it has 1 here and 1 here, so it has 2 acute angles. Question 16. Mike drew the figure with opposite sides parallel. Oh, sorry. Write the pairs of parallel sides. So this is a multi-step question. I can see that this is 1 pair of parallel sides. I can also see that this is a pair of parallel sides, but I need to write that. So when we do this, I can say segment DG, and this is the symbol for parallel, is parallel to segment EF. That's 1. I can also see that segment DE is parallel to segment GF. Okay, so I've written the pairs. Then it says, what figure is it? Well, a figure that has 4 sides and opposite sides are parallel, which means 2 sets of parallel sides, is a parallelogram. Okay, the next one, circle the letter that does not have line symmetry. So which one can I not cut in half? So I can cut my D in half, I can cut my O in half, I can cut my T in half, I cannot cut my S in half. Joseph made a pattern using ovals and rectangles. The first 4 figures of his pattern are shown. Draw the next figure in the pattern. So we can see it automatically starts with a circle. And then they've put a rectangle inside the circle. And then they put a circle inside the rectangle. And then they put a rectangle inside that circle. So I know my next step is to put a circle inside the rectangle. Jeremy drew figure 1 and Louisa drew figure 2. Jeremy says both of these are rectangles. Do you agree with Jeremy? Well, definition of a rectangle is any quadrilateral, a parallelogram has 2 sets of parallel sides and 4 right angles. So yes, they are both rectangles because they both have 4 right angles. Now part B says that Louisa says both figures are rhombuses. Do we agree? Well, a rhombus means it has 4 equal sides. So I'm going to say no because figure 1 does not have 4 equal sides. All right, on to the back. Veronica found the number of lines of symmetry for the figure below. How many lines of symmetry does it have? So we're going to look at how many different ways you can, how many different ways you can cut this figure in half to make it have line symmetry. So when we're looking at this, remember that line symmetry is not a mirror image. It has to be the same, like I folded it on top of each other. So I know that I can fold it right here. And if I folded that, they're the same on both sides. I also know I could fold it here and have it the same on both sides. But I can't fold it on the diagonals because they'd be the opposite. So it has two lines of symmetry. Okay, number 21. Jordan drew the pattern below. So first we're going to describe the pattern. Notice this one has 2 squares in it. This one has 4 squares in it. This one has 6 squares in it. This one has 8 squares in it. Okay. So we can see that each figure has 2 more squares than the last one. Then it says write a rule using numbers. So what this means is if I have a formula or an equation that I could use, I should be able to pick any figure that's ever going to be in this pattern without drawing them all. So I can see if the figure 1 has 2 squares, figure 2 has 4 squares, figure 3 has 6 squares, figure 4 has 8 squares, then you multiply, so the figure times 2 equals the number of squares. And for part C, we're going to draw figure 5. So I know if figure 4 has 4 in their rows, and there's 2 rows, then figure 5 would have 5 in each row. I also know using my formula, figure 5 times 2 should be 10 squares. So looking at this, here's my 10 squares. The biggest thing on these guys, make sure you're paying attention to the details of all the different rules with angles and quadrilaterals. Good luck on your test.